Hi, everyone. Thanks so much for joining us today. If you've just joined us, my name's Susie. I am a member of the Appier team, and I will be handing over the presentation to Dr. Min Sun shortly. However, before we do that, I just want to let you know how you can ask us questions. We will address those at the end of the webinar. On your screen, you should see an icon of a hand. So feel free to click on that and then type in your question, and we will respond to those after Dr. Sun's presentation on deep learning and app engagement. So I will hand it over to him now. So Dr. Sun, take it away.
Great. Thanks, Sushi, for the introduction. So I'm Min Sun. I'm the Chief AI Scientist in Appier. And before I joined Appier 1 year ago, I'm the Associate Professor from National Tsinghua University. So basically, I have about 15 years of experience in machine learning and deep learning. And that's why I'm very excited to share with you about how to land real valuable app users using deep learning for today. So let's get started. So let me first introduce Appier a little bit. So Appier is a technology company that provides artificial intelligence solutions to help enterprises solve their most challenging business problems. So since we founded in 2012, throughout those years, we have established 14 offices in 12 markets around Asian Pacifics. That including offices in Japan, Korea, Hong Kong, Singapore, and Southeast Asia, and India, and also Sydney. And throughout those years, our solution has been used and trusted by more than 1,000 leading brands, as you can see, some of them in this slide. All right, so that's a brief introduction about Appier. Let me get back to today's main topic. And first, I will give you an overview of the app marketing. So what's the state of app marketing these days? So I'm going to show you two figures. The one on the left is about global mobile in-app ad spending. And you can see clearly the spending is booming. So across 2016, 2017, and an estimation of 2021, if you take a look at the purple numbers, which is the Asian Pacific ad spending, we expect to see an increase of more than 100% spending from 2007 to expected 2021, which means the spending in Asia Pacific will actually more than double. And this is a relative more increase than the ad spending for the rest of the world. So clearly, the ad spending is booming. Another figures on your right, I want to share with you the share of global mobile app revenues. So in this figure, in purple, we're showing the in-app purchase revenue contributions versus the rest of app revenue contributions. So you can see that starting from 2011, there's only 6% of the revenue come from customers in-app purchase. But it consistently grow at this very strong pace all the way to 2017, where the percentage of in-app purchase amount to the ad revenue is almost half. And this shows that the user behavior has changed such that more and more users get used to doing purchase in their app events. So that means app marketers are moving one step forward to measure their success based on in-app actions. And to give you a better understanding, let's just illustrate a typical customer journey. So a customer will first receive the ads, and some of them will click on the ads, and some of them will eventually download the app and install them. Among them, some of them will have in-app actions that contribute to the revenue. So for app marketers, their KPI focus in the past might start with the cost per clicks and gradually moving to considering the cost per install. But in the future, cost per actions, including the number of purchase, the value of purchase, and how many users keep on using your app after install will be the key critical KPI of the focus. So that means maximizing customer lifetime value is the key to win the game. And why is that? It means why today's talk is very important. So before I talk about how to use deep learning in detail, let me just identify the two key challenges in app marketing. The first challenge is about user engagement and retention. 55% of the marketers consider that engagement and retention are the biggest challenge they faced. And why is that? For example, because still the app abandonment rate is about 21%, which is relatively high. That means it is quite challenging to find the valuable user will keep on using your ads and also have following on purchase actions. And the second challenge is about app install fraud. From statistics, more than 11% of all global app downloads were fraudulent installs. And that means it will cost advertiser about 700 to 800 millions per year. And that is astonishing. And that's where we can use deep learning come to the rescue and tackle these two challenges. And basically, the key message is the traditional human approach and tools that we have so far have limited capacity to make accurate predictions to find the most valuable app users and also to fight frauds. And deep learning is a much smarter way to verify which traffic is authentic and have high quality user that we should act upon. So before I talk about how to use it in more detail, let's just try to clarify the concept between artificial intelligence, machine learning, and deep learning. So artificial intelligence basically means an intelligent system built by humans, so it's an artificial system. And for app marketing, we want an intelligent system to predict which users are valuable users for us to act on. However, when we only talk about artificial intelligence, that only makes the goal very clear, but didn't clearly talk about what techniques we use to achieve this goal. So one of the very common techniques in artificial intelligence that people use nowadays is called machine learning. So machine learning allows the computer to analyze the data and predict which set of users are more valuable. And so far, about 28% of the marketing leaders worldwide are leveraging machine learning tools. So what about deep learning? Deep learning is in fact a more advanced subset of machine learning techniques that typically use multi-layered neural networks. And the power of such neural network is because they could process a large volume of both structured as well as unstructured data, which could be scattered and very abstract that human cannot really interpret. And deep learning itself still remains to be an undeveloped area for ad campaigns. And that is why in Appier we're aggressively deploying deep learning to enhance our solutions. And let's have a clear comparison between human approach in the left and also the classical machine learning approach in the middle, as well as the deep learning approach on the right. What's their differences? So human approach typically involve human experts to analyze dimension of variable from 1 to 3 variables to build heuristic rules. And that will typically process for about days or even to weeks. And that means the human effort is actually huge. In terms of the data process, it only can process data that makes sense to human. So at the end, you have a rule-based prediction model to use. And for the middle part, classical machine learning, this approach is a much scalable approach that could analyze multiple dimensions of variables. And after training the model, you can use the model in real time. However, it still causes a median amount of human efforts. And the reason is because using classical machine learning, the data always needs to be pre-processed by human. And in machine learning, we call this feature engineering. And every machine learning scientist knows that it is very critical to design good features, otherwise your machine learning performance will not be good. And at the end, using classical machine learning, we have a data-driven predictive model. So finally, on the right, we have deep learning model. It is not only a scalable approach, but it is actually learning the representation from raw data. It could also be applied to analyze multiple dimensions of variables. Once it is being trained, it could be applied in real time. But the most important thing is it only involves very few human efforts. And the reason is because it could process a large number of both structured as well as raw and unstructured data, which is potentially be scattered, abstract, and human can understand by itself. So at the end, you have a data-driven predictive model with a much higher accuracy compared to classic machine learning approach. And just to give you a brief understanding about how performance can be improved, comparing deep learning and human approach, I'm predicting what in-app event will happen. So deep learning model shown in the purple bars, in average, has a 70% improvement in prediction accuracy. And across 6 different in-app events such as open, watching tutorial, logging, and so on, we see a consistent improvement from 4% improvement all the way to as high as 35% improvement. All right, so that strongly motivates us to get the deeper detail about how we use deep learning. So let me first start with how to use deep learning to optimize campaigns. And in the first scenario, I want to focus on acquiring high-value new app users. So in order to apply deep learning in this scenario, typically that involves 3 steps. The first step is to analyze and collecting data as well as user in-app event histories. And for machine learning scientists, this is typically called preparing the training data. In the second step, once the training data is given, we're going to teach the deep learning model to predict which user is going to be valuable according to the feature or the digital behavior of the users. And this step for machine learning scientists is called training a deep learning model. So for the third step, once you have a trained deep learning model, you can use it to make predictions and basically adjust and optimize your traffic selection on a real-time basis. And the end result is marketers will see their advertiser KPIs improve significantly. And we also see that deep learning offers a shortcut for capturing high RAWs user compared to non-deep learning methods such as classical machine learning method. And there's a reason for this. So on the middle column, we are showing a system with the help of deep learning. Using deep learning, we could train a global representation to jointly predict registration event, product search event, as well as purchase event. They all share the same representation that we learned using deep learning. And among those events, typically you will have much more positive labels for registration and product search compared to purchase positive labels. And using deep learning, because we're sharing the same representations among all those events, the positive label for registration and product search can enhance the representation that we learn and better improve the accuracy on predicting purchase. Compared to a classical machine learning approach that do not use deep learning, typically you need to train a separate model to predict a different event. So in this case, you need to train a model that directly only predicts purchase. And in this situation, because you have fewer positive labels for purchase, your classical machine learning approach will not be performing as good as the deep learning model that learn a shared representation across all those different events. So let's take a look at some real-world campaign results, comparing the classical machine learning approach plus our system also applying deep learning. So here's a study between March and October last year that we test our deep learning algorithm on predicting in-app events. And we apply this technology and do the analysis on 244 app campaigns with 0.5 billion data points in 13 markets, including Taiwan, Japan, Korea, Hong Kong, India, and Southeast Asia, and China. So the result is super exciting. Deep learning optimized the most challenging KPIs. So the method using deep learning is again showing in purple, has consistently improved the retention rate, registration rate, booking rates, purchasing rate, and ROS values significantly compared to a classical machine learning approach. And we also found that deep learning drives better user retentions. In retention rates, in 1 day, the deep learning approach improved by 8%, retention rates in 3 days improved by 3%, and the retention rate in 7 days improved by 4%. So that's amazing results in the first scenario. In the second scenario, we wanted to do is reactivate dormant app users to increase their lifetime value. And this type of reactivating task is very different from retargeting tasks. In retargeting tasks, you always want to retargeting the active user that has many different in-app events. But for reactivating, we want to exclude those active users, but find the people among the inactive user which are likely to use your app again and also potentially to do more purchase in the future. And that is why we said by doing so, we could increase users' lifetime value. So in order to achieve this, the most critical thing is determining who are the right user we should target for reactivating them. For some of them, it is easy to use human intuition to judge, but most of them is going to be hard. So let me just show you some concrete examples. Let's assume we are facing two groups of users. Both of them hasn't been using your app for 7 days, but some of them has purchase history and some do not. So in this case, it is quite obvious for a human to choose to target at people who has purchase history, because it's more likely when they've been reactive, they're gonna purchase in your app again. So that's simple. Another simple decision is the following. Now you have two groups user, they all do not have purchase history, but one group hasn't used the app for 7 days, and the other group hasn't used the apps for 14 days. So in this case, it's also easy for a human to decide to target the people who hasn't used app for 7 days only, because it's more likely they will start using the apps again. But the truth is, there will always be a lot of comparisons that human knowledge cannot really judge. For example, in this case, one group has no purchase history and hasn't been using an app for 7 days, versus the other group has past purchase history, but hasn't been using your app for 14 days. So in this case, we need deep learning to the rescue. So here's a comparison directly comparing the rule-based segmentation approach and predicted-based model applying deep learning. So the rule-based segmentation method not only has this problem of not knowing exactly how to rank each segment, but it also has the problem that if we're using very few dimensions to create a segment, such as days of inactivities and also purchase or without purchase, if we're using only these few dimensions, inevitably each segment will contain some good user and low value users. So it is quite not optimal. In fact, what kind of raw data do we have? Let's take a look at the bottom figure. We actually have all the users' behavior after they install the app. So the first user, after they install the app, open app 3 days in a row. So we know exactly when they open the apps and what types of event they did in app, and also the duration of the event they experiences. And we're using a method called recurrent neural network, which is one type of deep learning method, to directly consider the event time, the event type, and also the event durations, as well as the sequence of different events happens in user history. And to directly predict who are the high value user who will convert more and who are the low value future users. And in our experiment, we show that performance improves significantly compared to the rule-based segmentation method. All right, so let's move on to talk about how could we use deep learning to fight advertisement fraud, which is our second biggest challenge. So in Appier, we have built a multi-layer anti-fraud systems using deep learning. And we are using deep learning to help minimizing fraudulent install at both the publisher and clique stage. And let's try to refresh everyone's memory. The typical customer journey is a user will come from a certain publisher and sub-publisher, and some of them will actually clicks, and after clicking, some of them will actually install your apps. And here, after a user installs the app, we could keep track of the in-app activity, and according to this information, we can know some of the installs are fraudulent and some of them are not. And using that information, we can post back to train a deep learning model to predict which publisher are better and also which clicks are potentially contribute to fraudulent install. So let me talk about these filters one at a time. So what happened in the publisher filter? So we're using a deep learning model to predict each publisher's one-day user retention rate. Before we're using this deep learning model, we might just simply treat all the publishers the same. Publisher A, B, C, D, they all will contribute to the same traffic volume. But after we use our deep learning model to predict the quality of each publishers, we might find that A and D publisher has a much better retention rate compared to B and C. And what we can do is to reduce the volume going through publisher B and C and increase the volume going through A and D. And that is what we call the publisher filter. Now, what happens in the clique level filter? So for clique level filters, we wanted to collect the features corresponding to each click, such as the data, the device type, time of click, created size, and so on. It will be a very high dimension of number of variables. And the goal is to predict invalid install. And we will have our rules to define what are the invalid install. For example, if the click-through install time is less than 10 seconds, then it's most likely to be a fraudulent install. Or the install device location is not the same as the targeting countries, then this is also a sign of fraudulent install. So using that, we have on the right the positive label for invalid install, and on the left have the high dimensional feature corresponding to each clicks, and we will train the deep learning model to predict according to the feature at the click level, which might eventually contribute to a fraudulent install. And once the model being trained, we could, in a real-time manner, filter out the clicks that potentially contribute to an invalid install in the future. So a case study that we conducted with Indonesia leading ride-hailing app developed companies using our multi-layer deep learning technology preventing frauds. Our result is very good. We basically can see that using this technology, we can increase the install rate by 119%. And increase the booking rate by 63%, and also decrease the customer acquisition cost by 45%. All right, so that's how we're gonna use deep learning to tackle the two big challenges. If you wanted to know more about how to capture and retain authentic high-value app users, you can download our latest white paper with the title Landing Valuable App User. You can simply scan the QR code over here, or you can contact us for personalized discussion with one of our AI specialists. And that's it about my today's webinar. Thank you.
Great, thank you so much, Dr. Sun. That was great. I believe we do, in fact, have a couple of questions. So hopefully everyone can stick around for a few more minutes. Okay, so the first one we have is, what do app marketers need to consider before applying deep learning to their marketing activities? What needs to be in place to do this most effectively?
Well, thanks, Susie. That's indeed a great question. So I think the most important thing you need to first make sure you have is a good data pipeline, because deep learning is a method that really needs to be trained with data, and it will strive once you have good quality data and a very robust data pipeline. And for app marketing, it's also very important that you have a data pipeline, have the most recent update of human online behaviors. So I would say the key component is you need to have a robust and also robust and very recency update data pipeline to support your deep learning model to success.
Great, thank you. Okay, we have one or two others. So One of our attendees, is asking, is deep learning more effective for any particular type of app or within any specific industry?
I see. That's a good question. So actually, in the talk, I mentioned that we have conducted a pretty large and wide number of experiments across, I think it's 200 something, some campaigns. So we do have a lot of experience on various types of campaign. So first of all, we found that across all types of campaigns, applying deep learning can indeed outperform the classical machine learning method. So in that sense, it doesn't really preventing us to apply deep learning in any kinds of campaign. We basically promoting all the campaigns to try this. But across different campaigns, there will be some campaigns that originally has a number of installs, let's say close to 100 per day. For those types of campaigns, it is good because you already have many positive labels for install or purchase, so you can directly leverage deep learning powers for those campaigns. And for some campaigns, you don't originally have close to that volume of install or purchase, but you might have some other app events available. For example, registration, search types of app events. Then in Appier, we're using those events as a positive label as well to train a good representation for deep learning model. So we do also see deep learning method outperform classical machine learning for those types of events as well. So the conclusion is we think there's a great chance to improve upon your previous method that only use human rules or using classical machine learning. So please come to us, talk to our AI specialists to find out more.
Okay, great. We have another one here, which is that as app fraud has the potential to get more sophisticated, can you explain how deep learning will keep up with that or stay ahead of those future threats?
Right. This is a very great challenge. It's about the second, great question. It's about the second challenge I mentioned during my talk. Yeah, indeed, the ad fraud will also advance because behind the scene, people are trying to do this proactively. So the power of using deep learning here is because we could always collect some new evidence of invalid install and quickly update the model. Right. So inside Appier, we are continuously monitoring the performance of our fraud prevention systems. And whenever there's a sign that some unseen pattern has introduced a invalid install, then we could quickly, through our very robust data pipeline, collect a new set of updated training data and update the deep learning model according to that. And compared to classical machine learning, which could also be retrained, the advantage of deep learning is because we are learning the predicted model from very raw data, whereas classical machine learning approach requires human feature engineering. So many times when the fraudulent behavior has changed, for classical machine learning model, you will potentially need a human involved in the loop and take a look at the data and redesign a new set of feature, which is good at catching this new pattern for fraudulent install for classical machine learning approach. So yeah, I would say in this case, deep learning also strive better than the classical machine learning approach.
Okay, thank you. I think we have one or two others that our administrator is just sharing. So we could hold on for just a second or two. Okay, so Dr. Sun, will deep learning replace traditional machine learning, or does it depend on each use case?
Yeah, so it's a very great question. It's a very also a broad question. So I would say deep learning clearly has advantage over classical machine learning under two assumptions. First of all is in the case when you have a large number of data coming in, and that is true for digital marketing because everyone is running a lot of campaigns, and we will post back the campaign for performance. We have this criteria of our labels are self-labeled by the ecosystem. So you don't need a huge number of humans to do the labeling. And also in digital marketing, we have many different predictive tasks, as I described. For in-app events, we have registration, tutorials, and some other playing events in gaming, and also purchase. Because we have many different predictive targets, that it's also very good for deep learning to jointly learn a multi-label prediction task compared to a classical machine learning. So I would say in digital marketing, we're going to gradually see deep learning approach is consistently outperforming classical machine learning based approach. But in other applications, when getting labeled data is costly, and also the predicted tasks do not have any correlation. They are basically independent. And in this case, you will face the problem that you don't have much label training data, and each task are totally different. And for those cases, classical machine learning approach will still be the best choice to try at the first stage. So yeah, so I think depends on the problem domain and the data, the type of your data, then you will choose either deep learning or classical machine learning. But in digital marketing, we're seeing a clear evidence that transforming from using classical machine learning to deep learning is the trend. Yep.
Thank you. Okay, we have another one here. Can deep learning also help app marketers determine the best content to reach customers, and not just content, but in fact, the best time to share that content?
Oh, yes, indeed. Yes, deep learning model, because it will analyze a high dimension of variables. So in this case, we could define, we could take the raw data that characterize your context, such as your content title, you can take the content image, you can take the content category as raw feature to fit into the deep learning model. And in terms of the timing, you can choose which o'clock amount each day, what weekday amount each week, and also even feature about how close this date is to a certain holiday. We can all feed those information into a deep learning model. And the deep learning will learn how to combine those content feature as well as timing feature and figure out some set of content is most successful to target user, for example, at a later day in the evening, or some of the content is easier to target user in the weekend. And we have consistently seen this kind of characteristic happen in our trained deep learning model.
Great, thank you. I think we might have time for one more from the audience. So our administrator is just going to send that over, if you'll give us another couple of seconds.
Yeah.
So we have, as I said, time for one last one from the audience, and here it is. So would this work for branding ads, not app installs or any conversions?
Yeah, so yeah, definitely. So although today I talk about in particular the new app user install and also purchase, but in fact, deep learning could be applied as long as you have post-back metric about how good is the algorithm performing. For example, for branding ads, as long as our customer can post back, for example, how many people, uh, because of the ads, actually visit your website, how many people visit how many pages in your website, how many people actually go on your website, become a registered user or filled out a survey. So any signals that could post back from our customers will become a learning signal for us to train our deep learning model to optimize for. So yes, the answer is correct. We could also apply the same method for branding ads.
Excellent. Thank you so much, Dr. Sun, for sharing those additional insights. So I think we will wrap up our presentation for today. So thanks so much to everybody for joining us. If you have additional questions, you will have seen Dr. Sun's email there on the last slide. So feel free to contact him. You will also receive a recording of this webinar if you want to take another look at any of the content. So thanks so much again, Dr. Sun. Thanks to all our attendees, and have a great weekend, everybody.
Thank you, everyone. Thanks, Susie.